my teammate Charles. Today, we're excited to dive into our physics project, and the title is The Impact of Blade Pitch Angle on Wind Power Generation Efficiency. So to begin with, we live in a digital era that renewable energy is not an option, it's a necessity. But to make the wind energy effective, we need to make sure every detail is optimized. So today we're going to talk about, we change a few angles of blade pitch can make everything change. So let's start it.
As high school students interested in physics, we know wind power is a key to a green future. But we notice that the turbine blades aren't just flat, they are tilted. Our object was to find the optimal pitch angle. We asked ourselves, is there a perfect degree where the wind's energy is most efficiency convert into electricity? That's what we set out with.
Next is our experience variable. So first, we told you what is control variable. This is the thing we need to control. Okay, so first is our rectangular carbon. So this is used for our blade pitch. And now I'll show you how big it is. Look here. You know that this is our long side. This is our short side. So here is 15 centimeters. Here is 6 centimeters. So we use sine. Look here. 90 degrees. So we use 15 times 6 and we times sine 90. So we can see our result is 90 squares. Okay. I believe that you all know how it works. Next, we can see here, we use 3 pieces. And then each piece weighs 11.12 grams. Okay, number 2, wind speed is 4 meters per second. And we often use kilometer per hour. So I change it for you. Look here. 4, we need to time 3,600. And we divide 1,000. Here, 0, 0, 0, 0. 10. 4 times 36, 144. So it's what? 14.4 kilometer per hour. Next. Number 3 is 6 magnets and 6 coils. And this is used to generate our power. And the instrumental idling value is 0.064 new watt. Next one, we're talking about independent variable. And this is the variable that we need to change. So obviously, it's blade pitch angle. And we use 15, 30, 45, 60, 75. And then we use, next one is dependent variable, and it's power output. Okay. Next is our experimental procedures. And before we talking about these topics, I'm going to show my favorite scientist. He born in America and famous in the revolution of science. And my favorite speech in my entire life is this. Science is repeatability and reliability. According to this spirit, our first step is calibration. And this is to zero our instruments. The purpose of this is to 降低 our mistakes. And next is set up. You can see the picture of this. This is our main machine, and this one is the blade pitch. And set up means we set up the distance is 3 centimeters from the main machine and the blade pitch. Third one is testing, and this I will invite our teammates because he's the expert of this.
Okay, testing. We let it to a steady state, meaning it stopped acceleration, and we recording 60 seconds. And fourth is repetition. We repeat it 3 times to find average. And finally is recalibration. We recalibrate to make sure that the fabrication pattern shift our angles.
So this is our experimental results. And look at this table. There we look 15 degrees and 30 degrees. We can see the peak of the energy output is like 21 or 22 microwatts. And by the way, 45 to the 75 degrees, the output is all below 10 microwatts. And we see the 75 degrees, even see 0.9 microwatts. So we can see that the energy output is highly sensitive to the blade pitch angle. Next is our results analysis. And when we see this graph, we can see there is a strong negative correlation. So what is negative correlation? I'll give you a simple example. See here. We all learned the Newton's second law is the F equals ma. And F is force. And when we have the same force, the mass and the accelerates will have a negative correlation. Okay. Next is our actual findings. And why will happen this phenomenon? When the blade pitch angle increase, the power output will decrease. Why will this happen? And in fact, the smaller angles, the air deflect in a way that creates a strong lift force. So it pushes the blade faster. And at larger angles, the blades act more like a wall, so it creates a drag and turbulence, so that the blade cannot rotate faster.
No experiment is perfect. So now we are talking about the experiment error. This material strength. When you see paper board, it is too soft and it's easy to curve. So it's hard to steady the state. Also, airflow consistency. This low power output, because we're using milliwatt, and milliwatt is a mini unit. It's very hard to define this result. And the result is a little accuracy. This is the end of this video.
And if you like our video, you can press the subscribe button and the like. If the like over 5,000, we will film the next video. So don't forget to press the like button.
Thank you.
Thank you everyone.
That's all.